All right, so today we are going to discuss matrices in finance and how we can use Desmos to help us with these types of problems. On this first slide here, this link, if it lets me click it, is going to open the help page for the Desmos matrix calculator. And on this page, there is a video with getting started. It's going to kind of go through all of the similar things that I'm going to go through, similar examples. So you can also watch this if you want to see another example. It also does break down how you can enter your matrix, adding rows, columns, performing different operations that are there, such as powers, determinants, reduced row echelon form, how to work with multiple matrices, what happens if you get this little error symbol. So a lot of the same things I'm going to discuss here, there is at the Desmos Help Center. But we are going to work specifically with the Desmos matrix calculator. So if you just go to desmos.com, you have more than one calculator. We don't want the graphing calculator. I want to use one of the other calculators here. So if I click Math Tools, it's going to then give me the different options. So graphing, scientific, this is where you got your geometry tool. There's also a 3D calculator, and then we're going to work with the matrix one. Okay, so let me minimize this for just a second here. So we can see the matrices that we're going to work with. So for all of these problems here, we're going to work with A, B, and C, 3 different matrices, 2 by 2 for A, a 2 by 2 for B, and a 2 by 3 for C. So remembering that the dimensions are rows by columns. So A is a 2 by 2, 2 rows, 2 columns. C is a 2 by 3, 2 rows, 3 columns. And in linear algebra, one of the things we do is basic matrix operations, adding them, multiplying them, finding the inverse, finding the transpose, and then working through some other things, multiplication, reduced row echelon form, determinants, things like that. So the first thing I am going to do is enter my 3 matrices into my calculator here. So default setting is a 2 by 2 matrix, which works great for this first one here. I have 5, 0, -1, and 2 is matrix A. Matrix B is -3, I think that's 8, -5, and 10. And then for C, I need to add a column here so that I can enter my numbers 1, -2, -3, 2, 3, and -1. So my matrices are there. And then anything I want to perform, I can just use all the extra little buttons here. So the first problem wants us to do matrix A plus matrix B. So I'm just going to click A plus B. And if I can do the operation, it's going to show me the answer right here. So the first problem's answer, matrix A plus matrix B, is the matrix 2, 8, -6, 12. So when you're doing the work, you can either write your answers on the document here or just upload your Desmos screen and I can read your answers right from that. Next thing you want to do is scalar multiplication. So we want to multiply matrix A by 3. So I'm going to do 3 times matrix A. And everything in matrix A should be multiplied by 3. So making 15, 0, negative 3, 6. Next one wants us to find the inverse of B. So I'm going to hit B, and then the inverse is right here. You see that negative 1 power, that stands for the inverse. So if I click that, it is going to default give me the answer in decimals. So if I like decimals, okay, that's fine. If I want to change it to fraction, I can click that little button there. And it's going to convert between decimals and fractions. So this is preference for you, whether you want it as decimals or fractions. Either one is okay. I did mine in decimals, so I will write mine in decimals here. 1, negative 0.8, a half, and 3/10. Negative 3/10. Next one wants to do the transpose. So basically, what was a row now becomes a column. And that function is available in Desmos as well. So next one is take C and find its transpose. So that's this button here. And you will see that the rows have now turned into the columns. So 1, 2, negative 2, 3, negative 3, negative 1. So that first row, 1, negative 2, negative 3 is now the first column. And the second row is now the second column. I can also do matrix multiplication. So we want to do A times C. And remembering that if we're going to do matrix multiplication, in order for it to work, the dimensions, the middle dimensions have to be the same. So A is a 2 by 2. C is a 2 by 3. And as long as these middle dimensions are the same, we will be able to get a result, and it's going to be a 2 by 3 matrix, 2 by 3. If these middle ones are not the same, you're going to come up with an error button, and it's going to say dimension mismatch, or it says something when you hover over it. Okay, so let's do A times C. We know this one's going to work. So I can just pull it up here, do A times C. And we do get an answer here. So I'll write that on the slide. 5, negative 10, negative 15, 3, 8, and 1. Next, we want to row reduce C. So remembering that when we row reduce, our goal is to basically solve the system of equations that's listed there. This function or system that is in C would be 1x minus 2y equals negative 3 and 2x plus 3y equals negative 1. So this is a augmented matrix where your x and your y's are here and your number that it is equal to is on the right hand side. So when we row reduce a matrix, our goal is to solve then what is x and y. So we can go to Desmos here. I'm going to hit RREF, that stands for Reduced Row Echelon Form of C. Now for this decimal is a long decimal. It would be best in this case to put it in a fraction form. If it's a nice round decimal, 1, 2 places, okay, fine, leave it as a decimal. But when the decimal does fill the whole amount there, please go back to a fraction form to make it an exact answer. So let's write this answer here on our slide, and then I'll explain what we just found. So 1, 0, negative 11 sevenths, and 0, 1, 5 sevenths. So what this is telling me is that x is equal to negative 11 sevenths, and y is equal to 5 sevenths. And if I were to plug those values into this original system of equations, that is the solution that works for both of the equations. That is the intersection of both of those lines. So reduced row echelon form is finding the solution for the system of equations. I can use it for a system of 3 variables and 3 unknowns, 4 variables, 4 unknowns. I have that option. So depending on the number of equations I have, I can use matrices just like I use substitution or elimination or graphing to be able to find that solution. Next one wants us to find C times B. So again, we're doing some matrix multiplication here. So if I do C times B, all right, I get that little error icon. And when I hover over it, it says cannot multiply matrices with incompatible dimensions. So that means this is not going to work. It is undefined, or you can say incompatible dimensions. So undefined. Whoopsies. Sorry, I don't know why it jumped forward there. Mismatched dimensions, however you want to write it. Dang it. It keeps jumping forward. Okay, another thing we can do is find the determinant. Remembering that the determinant of a 2 by 2 matrix in the form A, B, C, D is A times D minus B times C. So I could do that here. I could have multiplied negative 3 times 10 is negative 30, and then subtract negative 5 times 8, so subtract negative 40. So it'll be negative 30 plus 40. It should give me an answer of 10. So I could go back and double check that that's the same answer here. So, oops. Let me clear that out. Determinant of B is in fact 10, just like I said. And then the last one wants to combine scalar multiplication with subtraction of the two matrices. So 4b minus 2a. So 4b minus 2a gives me this matrix here, negative 22, 32, negative 18, 36. Oh my goodness, my pen is not working right today. All right, so hopefully this is just a quick little review for matrices, matrix operations that you have done in your other math classes. So just another tool to use when you come across matrices or solving systems of equations that is for free. So the next section we're going to work on is finance, and we're going to look at two different types of finance problems. So the first type of finance problem we're going to work with is called compound interest. The formula for compound interest is A equals P times the quantity 1 plus R over M to the MT power. Some books use N instead of M. It just depends on which you're looking at. Basically, A is the amount. P is the principal or initial investment. R is the rate in decimal form. So for example, 70% is 70 out of 100 or 0.70. 5% is 5 out of 100. Percent literally means per 100 or 0.05. Says here, M is the number of compounded periods in a year. So 2 represents semi-annually, 4 represents quarterly, 12 represents monthly. If it was weekly, it would be 52. If it's daily, it would be 365. And then lastly, T is the number of years. We are not going to use the formula here and solve these by hand because Desmos has a pre-built calculator. And what's awesome about it is it lets us solve for any one of these variables. We can solve for the amount, the principal, the rate, or the time. So this link here is the one you can use. It is also listed in the week 4 folder under the Desmos links. So let me get that one opened here just so I can show you what that is going to look like. Do know that they use a few different letters in their formula than we do. So their future value is F. That was our A. So our future value, our amount in the account is F. P is the same. They use I for interest rate, and they use N for the number of periods. So what we need to note is here in this calculator, our A is equal to their F, future value. P is equal to P. That is fine. Okay, the I believe, let me just double check here. So the interest rate when I do this is going to be the R over the M. And their N is equal to our MT. So the formula they're using is F equals P times 1 plus I over, or sorry, 1 plus I to the power N. So N is M times T, I is R divided by M. Those are things you're going to need to know as we solve these problems. So if $100 is invested at 6% compounded, and we're going to do a few different examples here, what is the amount after 4 years? So this is our P. This is our interest rate R. So when we want to find the future value, in Desmos, our P is 100. Our I is going to be equivalent to our rate divided by how many periods we have. So when we do A, that's going to be 0.06 divided by 1 because my interest is being calculated 1 time a year. When I do B, 6% is quarterly. That 6% is how much you earn per year. So per quarter, I have to divide that by 4. And then for C, that 6% annual interest rate needs to be broken into how much I earn per month. Then what is the amount after 4 years? So then the N value is the value here, 1 times the number of years. So I earn interest 1 time a year for 4 years, a total of 4 times I earn interest. When I do quarterly, I earn interest 4 times a year for 4 years, or 4 times 4, which is 16 times I've calculated interest. When I do C, I've earned interest 12 times a year for a total of 4 years. So 4 times 12 is 48 times I have earned interest. Once I have those values ready to go, I can go to the calculator and enter what I have. So I'm investing $100 at 0.06 divided by 1, 4 periods. And this answer is going to pop up right here in this box, number 5. So I would earn, after 4 years, I would have $126.25. $126.25. Now I want to redo this with my other values. So now I'm going to do it quarterly, and that gave me 16 periods of interest. And now my total in my account is 126, if I round that, 90, 126.90. And last one, interest is calculated monthly, and that meant there were 48 times that I got interest. This one ends me with $127.05. Okay, so Desmos does require you to do a few intermediate steps here of calculating the interest rate and calculating the number of periods. So you'll want to do that on the side so that you can then plug it into the calculator. And then you can always double check your answers by using your formula. 101 plus 0.06 over 1 to the 4th power. And if you type that in your scientific calculator, you will get a matching answer. The really nice thing about this calculator is that I can then solve for any of the other variables. The next one we're going to look at is, how do I find the present value? If an investment company pays 8% compounded quarterly, how much should you deposit now to have $6,000 3 years from now, or $6,000 6 years from now? So this is my goal. This is my future value, is $6,000. In order to calculate my interest, it's 8% compounded quarterly. So 0.08 divided by 4. How many times am I going to earn interest? Well, that is quarterly for 3 years. So quarterly 4 times 3, 12 times I'm going to earn interest. It wants to figure out, what do I need to invest right now? So rather than taking the equation, and solving algebraically, you can use the calculator here. And now, instead of solving for future value, say, I want to find my present value. I want to have $6,000. My interest rate is 0.08 divided by 4. And the N I calculated was 12. So if I only have 3 years to raise that $6,000, today I would have to invest $4,730.96. So $4,730.96. If I have 6 years, I still want to reach $6,000. My interest rate is still 0.08 divided by 4 quarterly. That didn't change. It's just the number of times I got interest is now different. I'm getting that 4 times a year for 6 years, for now a total of 24 interest periods. So the only thing I'm changing in my calculator here is the number of periods, 24, And that would mean if I have 6 years to reach this goal, I would only need to invest currently $3,730.33. $3,730.33. Now, this one isn't too difficult to solve algebraically, but if I go to ask you to find the rate or the time, that involves a lot more algebra with working with natural logs to undo these powers of exponents and things like that. So again, we can use Desmos to help us reduce the error that can happen when we solve some of these algebraically. Find the rate that makes $10,000 reach $27,000 in 10 years compounded annually. Okay, so this is your initial investment. This is what your goal is, your amount or your future value, and 10 years compounded annually. So this means your M is 1, your T is 10 years. So if I wanted to calculate N, 10 times 1 is 10. Now, if you were to solve this by hand, you'd have to do 27,000 equals 10,000 times 1 plus r over 1 to the 10th power. And this is going to then involve having to get rid of this exponent. So you're going to have to take like a 10th root, and then there's a bunch of steps involved there. Or we can just go to our calculator here and say, well, now I want to solve for the interest rate. So I am investing $10,000 with a goal of $27,000. And the interest periods, the number of times I'm getting interest is 10. 10 times I'm getting interest. All right, so down here is going to give me my rate in decimal form. So in order to get this, I would need a 10% interest. So when I do this, interest is 0.104. So in order to turn that back into a percent, if I times by 100, that's 10.4% would be my interest rate. And this calculator also lets me solve for time. So how long will it take 4,000 to grow to 9,000 if it's invested at 7% compounded monthly? So initial investment, 4,000. Future value, or your A, is 9,000. So 9,000 equals 4,000 times 1 plus. All right, my rate, 7%, 0.07 divided by 12. And then that would be 12t power. And once that variable gets put in the power, that means after you get rid of that 4,000, you then have to use logarithms to get rid of that t and the exponent. Again, lots of algebraic work that we can just use our calculator here to help us with the answer. So I'll close this one and go to the number of periods. So I have $4,000 that I want to turn into $9,000. Oops, 9. The interest rate we said was 0.07 divided by 12. And we are going to get here 139.4. Now, we need to think about this in terms of the problem. So N was 139.4. What we calculated was monthly. So this is months. If this was quarterly, this would be quarters. And then what you could do is you could turn this back into years. So I could divide by 12, because there's 12 months in a year, and get about 11.6 years that it would take my $4,000 to grow to 9,000 at 7% compounded monthly. right, so let's double check that that is the correct answer. So I could do 4,000 times 1 plus 0.07 over 12 to the 12 times 11.6 power. And I should get just about 9,000. Do note that we are rounding here, so there is a chance of it being just slightly off by a few cents. But I can go down here. So 4,001 plus 0.07 over 12 raised to the, I used shift 6 to get that value there, 12 times, oops, nope, I want to be in the exponent still, so I'm going to put it in parentheses, 12 times 11.6. Okay, so because I rounded that 11.6, it is saying I'm just a little shy there. So basically just telling me that my rounding was a little off, but I did get very, very close to 9,000. So I hope that makes sense with those problems. And just remembering that each time you do one of these, you're going to want to calculate your I and your N. Just remembering that I is R divided by M and N is M times T. You have the option to do these by hand if you truly want to, if you're more comfortable with that. I just thought the Desmos calculator was actually a really cool option, and I use it when I teach finite, and my students really do enjoy the fact of not having to calculate all of these out by hand. The next type of example that we're going to look at is what's called annuities and sinking funds. So basically what's happening now is rather than just, so compound interest is you put money in one deposit and just let it sit. For annuities and sinking funds, what you're doing is you're either putting in a periodic value, periodic payment. So maybe I'm putting in $200 every month and wanting that money to grow. Or the sinking fund is the opposite. You're withdrawing a certain amount every so often. So we're going to have a different formula here. Future value equals the monthly payment times the quantity 1 plus I, remembering that I is R divided by M, to the nth power, remembering that N is M times T, minus 1 all over I. So as you can see, the formula is getting even more difficult with the amount of variables and steps that are going to be involved in solving for them. So it is nice to have a calculator that does that for us. Here are some examples for future value. We want to find the future value if my monthly payment is $500, the I is 0.03, and the N is 20. So let me get our next Desmos calculator up here. This is the one titled Desmos Future Value. The one we were using before was called Desmos Compound Interest. And we want to start with future value. So there are here is the monthly payment. Our monthly payment is $500. Our I is 0.03 and N was 20. And the value that's going to pop up here in the next box is the total amount that's going to be in my account after those 20 periods. So I would have $13,435.19. So let's look at a word problem. In order to accumulate enough money for a down payment on a house, a couple deposits $300 per month into an account paying 6% compounded monthly. If payments are made at the end of each period, how much money will be in the account in 5 years? Okay, so my payment that I'm putting down each time is $300. We need to calculate the interest rate, 6%, 0.06 monthly divided by 12. And then I need to figure out how many times I have calculated interest. Well, that's 12 times a year for 5 years, or 60 times that I've calculated interest. So we will go to our calculator here and enter all of those values. So 300 we have 0.06 over 12. And then N is 60. So after those 5 years, I would have $20,931.01. And just to do a little bit of understanding here, you put $300 into this account 60 times. So just to show you what the difference is here, you did $300 60 times. So you put $18,000 in, and the interest got you up to $20,931. So $2,931 was gained in your interest. Just like the other problems, we can solve for the other values. So I could solve for the payment. One option is I could rearrange the entire equation, or I can just use Desmos. So we know our future value is $5,000. I have 15 periods that I'm depositing money and earning interest, and the I value is 0.01. What monthly payment makes this happen? So we will go to our calculator here, and now I want to solve for the payment. So solve for payments. I want $5,000. Oops. The interest rate is 0.01. Sorry, the I is 0.01, and that's 15 periods. So that I that has already been calculated for us. That means if we scroll down here, our monthly payment would need to be $310.62. Looking at a word problem, it says Sun America offered an annuity that pays 6.35% compounded monthly. So there's going to be my interest, 0.0635 over 12. What equal monthly deposits should be made to have $200,000 in 15 years? So 15 years times 12 times a year, and that is a value of, and actually, if you don't know that math, we can also just type that into Desmos. So you don't always have to calculate that part out. So let me show you that. We want 200,000. We have 0.0635 over 12. And then I could do this here, 15 times 12. So I don't have to do that math beforehand. I can actually just type that in here, and that would be equal to 180. And then this down here is my monthly payment. So $667.43 would reach that $200,000 goal. $667.43. think I skipped the next problem. I'm just going to verify that I don't have you do one of those. Yes, okay, I don't have you do one like the next one. So we're going to skip this one and just go on to this guy here. I just wanted to make sure that I wasn't skipping a problem I had you do. Last problem. You can afford monthly deposits of $200 into an account that pays 5.7% compounded monthly. How long will it be until you have $7,000? Round to the next higher month, if not exact. So our monthly payment is $200. Our future value is $7,000. And our interest is 0.057 divided by 12. So for this, we are looking for the T. How many years? Month. It wants to keep it in terms of months, so we don't have to actually change anything. So I'll go back to my calculator here. And I want to solve for the number of payments. So we afford $200 payments. Our goal is $7,000. And our interest rate, we said, was 0.057 divided by 12 because we're doing monthly. So the value we're going to get here is months. So they said to round up to the next one. So 32.45. So round up. It doesn't matter what you get. They want you to round up to 33 months. And that's likely why the one we did a few slides ago was a little low, because we didn't actually round up to the next whole value. We just said, oh, it's this portion of a month, when we should have actually rounded up to the next whole month. And then we probably would have been a lot closer to the exact answer. So I can go back just if you want to look at that one while we're talking about it here. That was this guy here. So rather than 193.4 months, I would say 140 months. And 140 months would be, let's see, 140 divided by 12 would be 11.7 years. And I bet if we used that value, we would be a lot closer to the 9,000. So let me go here. So let's say if we use 11.7, yes, now we've reached our goal and we've actually surpassed it. All right, so I hope that all makes sense and you can see how these would be helpful for you. You are going to practice matrix operations and then some word problems, just like I have done here for the finance. So if you have any questions, please reach out to me. Next week, we are going to be on campus in person, so please make sure that you are there for that. I would like to at least schedule a quick meeting with each of you here. So if you could email me with that availability, just so we can touch base before next week. Otherwise, I will see you next week.